Hey guys, so I actually got called into work at my other job tonight, and I got home and it's kind of late, and we have school tomorrow. But I wanted to go ahead and get this video made so that you guys can continue working on your tasks that are due on Monday, and have a lot of time to work on those. So today we're going to be talking about ratio tables and graphs, how we can take what we have learned with ratios and turn them into tables and graphs. This is a way for us to visually represent the kind of proportional and relationships that we're seeing with these ratios. So let's just do a quick graphing review first of all, so that so that when I'm asking you to graph these ratios and graphs, and graphs these ratios and put them into tables, put them on a graph that you know what to do. So first of all, we're going to do number one in green. So the x-axis is the one that goes horizontal. Okay, this is the x-axis. And the y-axis is the one that goes vertically. So that is the y-axis. And when I say axis, I mean these lines here. Okay, not very straight. There you go. And then the origin is where the x-axis and y-axis meet. The coordinates of the origin are always 0, 0. Now, when we plot points, we always label the x first, and we always label the y second, like you're seeing in the alphabet. W, X, Y, Z. X comes before Y. So I'm going to go ahead and label these for us. Go ahead and do everything I'm doing on my screen. You should be doing on your paper. All right, so I'm going to change my pen color to magenta to plot the point 2, 4. So I start at my x-axis. Since it's positive, I go right 1, 2, and I go up 4. 1, 2, 3, 4. I'm going to plot this point here. This doesn't have a letter with it, so we're just going to call this A. Here we go. So I just plotted point A, and then I'm going to switch my pen color to blue, and we'll call this plot B. So I go back to my origin. This time it's -2 and -4. 1, 2. So I go left 2 to -2, and I go down 1, 2, 3, 4 to -4, and I put my point there. And I'm going to label this B. All right, how are these 2 points related? They are so you're going to recognize some of this language. They are the same distance from the origin, which is kind of like 0 when we're talking about graphs, but they're in opposite directions. So they are opposites. The same, write this down please, the same distance from the origin. Okay, so there you go. We've got our graphing. Okay, so now that we've reviewed graphing a little bit, we're going to talk about how graphs can help us understand ratios. Before we start getting into graphing, we're going to start putting our ratios into a table. So what you are used to seeing, so I'll read the question first. Dale and Amante are planning a bake sale to raise money for the local food shelter. They want to make a lot of chocolate chip cookies for the food shelter. In each batch of cookies, they use 2 cups of chocolate chips. How many batches can they make with 12 cups of chocolate chips? So you are used to seeing equivalent ratios look like this. Let's go magenta. So you're used to seeing equivalent ratios look like this. So in one batch of cookies, they use 2 cups of chocolate chips. Okay? So we know, so batch and cups. Cups of chocolate chips. So we'll start with 0 and 0. That should be a given. So we know in one batch of cookies, they use 2 cups of chocolate chips. This is just like that fraction and equivalent ratio work we've been doing. So in 2 batches of cookies, to get from 1 to 2, you multiply by 2. They use 4. Now, some of you guys saw this pattern yesterday when we were going over the do now. So in 3 batches of cookies, if we're counting 1, 2, 3 here, 2, 4, 6. Remember, they only have 12. So when we get to 12, we need to stop. All right, 4. And we're not going to get to 12. All right, 8. Let's see here. We're going to split this. 5. 10 cups. And 6. 12 cups. So they can make 6 batches of cookies, of chocolate chip cookies with 12 cups of chocolate chips. And yeah, that table looks great. All right, so moving on. So this is what the table that I just created should have looked like. So now we're going to graph our ratios. So let's label our x-axis first. So even though these are written in a different way, these are still equivalent ratios. Let's go blue. All right, so let's first of all, we need to label this table, which is, the scale of this is terrible. Here's what you're going to do. You are going to ignore these zeros. We're going to divide everything on the y-axis by 10. All right, divided it all by 10 using math magic. So we are going to say that this is cups of chocolate chips, and this is batches. All right, so let's graph. So when we have 1 batch, we are using 2 chocolate chips, and then we just put a dot where these intersect. Of course, 0 is 0. 2 batches, we are using 4 chocolate chips. And because we don't have a perfect grid here, you guys can just estimate. 5 is 10, 6 is 12. Now, if you notice, this is going in a straight line, or it would be if it was easier to draw with this tablet thing that I've got. So this is going in a straight line. This means that this relationship is proportional. We're going to get more into proportions and how they relate to ratios in a moment. But for now, just understand that a straight line on our graph means that it's a proportional relationship. Okay, so let's practice. In the Tour de France, athletes from all over the world compete to be the fastest cyclists by riding every day for up to 8 hours. They're just riding a bike in the mountains of France for 8 hours. It sounds miserable. And I'm someone who once ran a race for 5 hours and 15 minutes on foot. In last year's race, American cyclists averaged a rate of 75 miles in 3 hours. Using this information, let's fill in the chart below and then we'll create a graph. So, this was not 75 miles in 1 hour, this is 75 miles in 3 hours. If this was a ratio, it would be 75 to 3. So, we have 3 hours, we know that's 75. Obviously, if they are not biking for any time at all, for 0 hours, they're going to go 0 miles. So, in 1 hour, we have to figure out, if they go 75 miles in 3 hours, we figure out how far they go in 1 hour. And that, guys, is just us using our equivalent fractions and equivalent ratios. So, to get from 3 to 1, we have to divide by 3. 3 divided by 3 is 1. 75 divided by 3 is 25. So in 1 hour, they go 25 miles. Again, so here we're counting by 25s. Here we're counting by 1s. 0, 25 in 2 hours. So 1 times 2 is 2. 25 times 2 is 50. 1 times 3 is 3. 25 times 3 is 75. We already got that one. 1 times 4 is 4. 25 times 4 is 100. 25 times 5 is 125. 25 times 6 is 150. 25 times 7 is 175. And 25 times 8 is 200. All right, now this scale looks a little bit more appropriate. We still need to label our axes. Just plural for axis. This is hours. And this is miles. I'm going to use our abbreviation for miles. You can do the same. All right, so start plotting our points. 1 hour, 25 miles. 25 is approximately, or is exactly, halfway between 50 and 0. So I'm going to put my dot approximately halfway between 50 and 0. And go ahead and fill in your table, I'm sorry, your graph as I fill mine in. And remember, if the number isn't represented exactly on the scale, you need to estimate about where it would be and place your dot there. All right, we went a little bit past our table, but that's okay. And we can tell that this is a proportional relationship because it's a straight line. All right, guys, so you're going to keep working on your tasks. Remember, you want to be done with task 6 by the end of the week, and then you will take another assessment on ratios and proportions. We are flying through this unit, which is a fantastic thing. All right, I will see you guys tomorrow.